Okay, so we're going to have a look at 13, question 13, and just do a few hints on this one. You actually had this in mock 2, your exam, and this has got two parts. The first part of this question is to use Newton's second law. Newton's second law, which is F equals ma. And the sum of the forces on the whole thing, sum of the forces, that means, is equal to ma, and in this case the whole thing is not accelerating, equals 0. So that means the force left is equal to the force right. Now we don't care too much about the force left and right, but we do care about the other directions that we could be interested in, which are the up and down forces. So you'll have a force down, which will be equal to the force up. So you've got to look at all the forces up, and in this case I'm going to help you a little bit, because the forces up are from here and here, and the forces down are the weight of the book and also the weight of the shelf, which will be the middle. So basically the first thing you've got to do is, this is called resolve vertically. And if you resolve vertically, you're going to be saying the up forces equal the down forces. And then the next thing you're going to do is you're going to take moments. And I think the easiest thing to do is to take moments about this point here, because that means that this force is not included. And the moments are the turning forces. So the turning forces, the thing to do in this type of question, turning forces in the clockwise direction must be equal to the anti-clockwise direction. So clockwise, the direction that a clock goes is this way round. This is the pivot here, so this way round. So any forces that are pushing in this direction times the distances away from the pivot. So it's going to be this weight of the book times that distance. And it's also going to be the weight of the whole thing, the weight of the shelf, times that distance there. And then the anti-clockwise is, and because we've ignored this one because there's actually no distance away, so that one, well, the distance is 0, so you don't need to worry about it. So we've only got one force that's going up, and that's B, and B is that distance away, and then we can find out what that distance is. Right, so that's a big hint for that question. And the second part of this question is, say, bracket B is moved closer. Well, if bracket B is moved closer, you know that the upwards and downward forces overall can't change, but it might well be that they have different forces, A and B, on them now. But what you do know is that the moment, the force there times the distance must be the same as it was before, so because otherwise it will start tilting. So the thing that you know about is the moment must be the same, and the moment, the turning effect, is equal to the force times distance. So the force times distance, due to the force at the point B times the distance of B from the pivot, must be the same. So if bracket is moved closer to the left hand, it means this distance has gone down, decreased. So you need to work out what's happened to the force in order that the overall force times distance is the same. Okie dokes.